So another reason my N could increases as my capital labor ratio increases is when I'm measuring my child rearing cost in terms of these other goods. And I can apply this kind of reason. So this can be another possible reason. So my N can relate to K in two ways, either because of migration or if I have my child rearing cost defined in this way, in terms of other goods. So when wage increases, these services they become more affordable to me, and therefore I am more. So I am in a better position to raise more children. So in that case, my N can increase. So these are the two possibilities that can happen. So is this clear?
Ma'am, I have doubt regarding the convergence.
Uh, which
Why it
question?
should be negative in the
Why this
same
is
question? Why? Yeah, yes, ma'am. Please.
so? Why this
Why
is
it should be
negative?
negative
See, if this
for
is
convergence?
not so convergence. So in very simple layman terms, what does convergence means? That eventually a point will reach when all the countries they grow at the same rate. So in very simple layman terms, I'm talking about convergence. So let's say if a country, if it is growing at a very high rate, then it will exhibit a, a lower growth rate after some time. And let's say country which is growing at a higher rate, sorry, at a lower rate, it will try to catch up by growing at a higher rate, and eventually it will grow at the same rate. So that means that as capital stock, this small k increases, my growth rate of capital needs to fall for convergence to happen. So eventually, we are like stabilizing. So I'm moving from different directions. Eventually, all these lines converge to one similar state. So for that to happen, if something is, so if this remains positive, that means my growth rate of capital, it will keep on increasing. So then uh, I won't move in this trajectory, I'll move in this trajectory, but I want a trajectory which should look something like this. So for that, I want this to be negative. Is it clear?
Yes, ma'am.
So question number 2, is it clear to everyone? Okay. Coming to question number 1. So first question is talking about explain the differences among absolute convergence, conditional convergence, and the reduction in the dispersion of real per capita income across groups. So absolute convergence. So how do we define absolute convergence? So absolute convergence is when poor economies they grow at a faster per capita rate than the richer ones, and this does not depend on any other characteristics of economies. So basically we assume that the economies they have the same saving rate, so they have the same saving rate, same population growth rate, depreciation, production function, everything is same. The only difference is the initial value of k. So in this case, what happens? In the case of absolute convergence, the poor economies they will uh, grow at a faster rate, and then they catch up with the rich ones, and in the long run, they all will grow at the same rate. Now, conditional convergence is when an economy grows faster, the further it is away from its own steady state. So in the absolute convergence, we assume that all the characteristics, so all the parameters, they are the same. So all the economies, they converge to the same steady state. So an economy which is growing at a slower rate, it will grow faster in the transition period, it will catch up, and eventually they'll reach the same steady state. But in the conditional convergence case, we assume that different economies, they converge to their own different steady states. So in the case of conditional convergence, we have different steady states because we have different parameters. So generally in the case of conditional convergence, we assume that S differs and my initial capital labor ratio also, this also differs. So since S differs, the steady state value will also differ. So therefore, all the economies, they converge to their different steady states, but an economy, so depending upon how far an economy, so let's say this is a steady state and one economy is this far away from the steady state, and one economy is this much away from the steady state. So this economy will grow at a faster rate and converge to its steady state as compared to the rate at which this economy converges to the steady state. So this is called conditional convergence. So conditional convergence is that all the economies, they will converge to their respective steady states, but an economy which is farther away from its steady state, it will grow at a faster rate to move towards its own steady state value. Okay, and this dispersion of real per capita income is basically we calculate the variance of per capita income. So this is basically, so this is basically you need to talk about this thing. So this term. So this measures the dispersion of per capita income. Now, this question, the second part of this question is asking you the absolute convergence. When would absolute convergence imply a decline in the dispersion of per capita income? Now, if you have gone through this handout, then you must have seen that it's not necessary that with absolute convergence, my dispersion of income would necessarily fall. It can increase or decrease depending upon where I am from the steady state dispersion. Now, this question is saying, when can we have this possibility that because of absolute convergence, we are sure that there will be a decline in the dispersion of per capita income over time. So, so for part B, let me give you an example. Suppose there is a family. So suppose there is a neighborhood, and there we have, let's say, 10 families. Now, in these 10 families, they have their kids. Now, in each family, they are giving nutritious food to their kids so that their children grow faster. So their height, uh, so they grow taller and taller. Now, if I calculate, let's say, variance of height in the neighborhood. Now, this variance of height would vary over time because I have 10 families, and these 10 families, although all these 10 families, they are giving nutritious food to their children, but I don't know how much protein and how much mineral, like what is the uh, basically the diet chart they are following. So probably some of the families, their food habits are non-vegetarian. So they would be able to provide more protein rich content as compared to a family which is It has more vegetarian diet structure. So in this particular case, if I calculate my dispersion of height over time for these children, my dispersion would vary. But suppose now I talk about a neighborhood where again I have 10 families, but these 10 families, they follow the same diet structure. So they have exactly similar food habits, they have exactly same income, their standard of living is the same. So their preferences for food, their taste, their habit, everything is same. So the kind of food they eat, that is also very same. So in this particular case, if I calculate my dispersion of height, would it increase over time or would it decrease over time? What do you think? What would happen in this particular case?
Ma'am, it may converge over time.
It may converge over time. So basically, my dispersion would decline over time. So this is one example that I have talked in terms of a neighborhood about households or families. Now we are talking about absolute convergence. Now you just have to take this analogy to answer this question. So absolute convergence would imply a decline in dispersion of per capita income only if the economies that I'm considering, they have exactly similar country characteristics. So they have the same per capita income, they have same investment decisions, they make same kind of investment decisions. So the country so they have the same government structure, law and order situation is the same, political scenario is same. So everything is almost similar. then then in that case only my absolute convergence would imply a decline in the dispersion of per capita income. So basically one line answer for this question would be that absolute convergence would lead to a decline in dispersion of per capita income if we study it for a group of countries that have exactly similar country characteristics. So everything is same, the political structure, the legal structure, everything is same. Okay, so is this clear?
Yes, ma'am.
Okay, so these are the only two questions that I had to discuss. Now, Ritika ma'am would be discussing the last two questions. Okay, and regarding my contact hours, so tomorrow, so not tomorrow, on Monday, I will be available from 11 a.m. So I will be in my office from 11 to 12. So in case if anybody has any questions, any doubt, they can meet me there. So my office is in room number 11.
Ma'am,
Yes.
can you please explain in A part this part reduction and dispersion of real per capita income across groups?
So this, uh, so if you have followed this handout, so basically it's talking about this only. So how do we calculate it? We make use of this. So we make use of this equation. So if I, let me just write a bit. So I am expanding this a bit. So if I bring this term to this side, this can be written in this way. So this is what log of yit by yit minus 1. So this is nothing but my growth rate of per capita income. So it depends upon uh, my log of YIT minus 1. So basically my level of, so I am just standardizing it by taking log, but basically my per capita income in the previous time period. So if I have absolute convergence, then B has to be positive so that this term becomes negative. So if we rearrange these terms, this equation can be written in this way. So here B denotes my absolute convergence. And here UIT is my error term, which is normally distributed. So given this, that my per capita income depends upon my income in the past in this way. If I have to calculate my measure of dispersion, I can calculate it in this way. So we are just using the formula for variance. So if I use the formula for variance, so log of YIT is so yi minus, so basically summation x minus x bar square by n. That gives me the variance. So we are just using that. So this UT is my mean value and I'm using this. So this is my measure of dispersion. And using this measure of dispersion, we basically see. So this is another way of seeing how does per capita income changes. So if this measure of dispersion is reducing over time, we say that so for a group of countries, if this measure of dispersion is decreasing over time, then we say that the countries more or less they are coming to a similar state of things. So this is another way of saying, but generally what happens that because of absolute convergence, it's not necessary that my dispersion of per capita income would necessarily fall. So we have another name for this. So this is called sigma convergence. So we have absolute. So there are three measures of convergence: absolute convergence, conditional convergence, and sigma convergence. So this dispersion measure, another name for this is sigma convergence. So sigma convergence is when the variance of per capita income it declines over time for a group of countries. Then that is called my sigma convergence. And this sigma convergence is a bit difficult to achieve because my country, most of the economies, they differ in their country characteristics. It can't happen that they'll have exactly similar country characteristics. That's not at all possible in the real world. So that is why sigma convergence is a bit tough to achieve in real world. Okay, so is it clear now?
Yes, ma'am.
Anything else?
No, ma'am.
Okay, then. So in case if anyone has any doubt, then that person can meet me on Monday between 11 to 12. And that's all for today. So if nobody has any doubt, I'll end this meeting.